Now let's make an NFT, and here's the good news. You already know most of what you need to make an NFT. NFTs are just SPL tokens, exactly like we made in the previous lesson. Just like other tokens, they are minted from token mint accounts, stored in associated token accounts, and transferred with the token program. However, NFTs have a few characteristics that are distinct. Firstly, they're unique, i.e., each NFT only has one ever minted. Also, they can't be broken up. In other words, each NFT has 0 decimal places. Additionally, the metadata for an NFT contains links to another file, stored on a file storage service like Iris or IPFS. This off-chain metadata file has links to media files like images, videos, or 3D objects, any traits the NFT has, links to the project that made the NFT, and more. Authenticity is also handled differently with NFTs. With regular tokens like USDC, we know they're authentic because their mint address matches the official USDC mint address. Since each NFT has a unique mint address, we use the concept of collections to verify that each NFT is actually minted by the right project, and not a forgery some person created. Let's go make an NFT.
Alright, so let's make an NFT. We're going to start by making a folder called new NFT. We will change into that, and we will run npm init-y to create a blank npm project, a package.json, and all those things. We're going to install a couple of packages as well. We want to install from the Metaplex Foundation a package called MPL token metadata, and also a package called, also from the Metaplex Foundation, UMI bundle defaults. UMI, by the way, is the Japanese word for sea. You'll notice a lot of things in Solana, like sea level, like anchor, have names based on seas or oceans. Cool, they're all installed. I'll just clear my screen. And let's go make a new file, and we will call it create collection.ts. So we have our create collection.ts here, and we're going to start, oddly enough, by making the collection. As I mentioned before, NFTs, unlike regular tokens, are unique. So whereas normal tokens have multiple tokens, many billions of tokens in some cases, or with a single mint address, each NFT has its own mint address. So there needs to be some way to bind all those NFTs together and also confirm that any new NFTs are actually produced by the owners of that collection. So that's why we have collections. So we'll start by making that collection, and we're going to import a few things. We'll take create NFT. Collections themselves, by the way, are also NFTs. Fetch digital asset, and what else? MPL token metadata. MPL is Metaplex. That's the company that maintains the Metaplex NFT tools. From at Metaplex Foundation, MPL token metadata. That looks good. It's just shown up as gray because we aren't using it yet. We're also going to import a few things from Solana helpers, and I should install the helpers as well. npm I at Solana developers helpers. So let's import a few things from that helpers file. That's airdrop if required. Get explorer link. Get key pair from file. From Solana developers helpers. That looks good. There's a few other things as well. We also want create UMI. Our UMI instance is just a way we can talk to Metaplex's tools. We can talk to other tools with UMI as well, but nearly all of the time, in fact, people just use it to talk to Metaplex tools. Metaplex Foundation, it is from UMI bundle defaults is the name of the package. There we go. We want a few things from Web3.js as well. That's actually already installed for us because it's a dependency of some of the other packages. We want connection, and we want LAN ports per URL from at Solana web3.js. Oh, and I haven't spelled connection properly. And, oh, lamports per URL. Lamports per sol. I don't know why I thought lamports per URL. That looks good. Excellent. So, we're going to create a connection. And we'll connect to whatever the URL for DevNet is. So, cluster API URL for DevNet. And probably also want to import cluster API URL as well. Oh. And we'll also want to import cluster API URL from Solana Web 3. So we have our connection. We'll want a user. So get key pair from file. If we don't specify the file to use, it's just going to use the id.json that's in our home folder. So that sounds good. And let's give ourselves some sol if we don't have any. So go await, airdrop if required. Connection to whose public key? The user's public key. Oh, I just realized I forgot the await. There we go. Await, get key pair from file, user.public key. And we want to get one Solana, so one lamperts per sol if our balance ever falls below 0.5 lamperts per sol. That looks good. Excellent. Let's also just console.log loaded user, and then we'll just say the user.public key. And probably want to say to base 58 so it prints out in the usual string of letters and numbers that we're used to seeing Solana public keys as. So let's make our Yumi instance. This is going to be, as I mentioned before, how we talk to Metaplex's tools. So const Yumi equals create Yumi. And we'll create our Yumi instance just using the same endpoint as our connection. So it's a Yumi connection to DevNet. We'll tell Yumi the programs we want to use, which in nearly all cases, as I mentioned before, Yumi is pretty much a Metaplex thing. So the programs you'll probably want to use are MPL token metadata. Sounds good. So MPL token metadata is actually a function. So we go yumi.use and then we run NPL token metadata. So we're going to make a Yumi version of our user key pair. So Yumi has its own format for key pairs. So we'll just call it Yumi user equals yumi.eddsa dot create key pair from secret key. And just say user.secret key. So this is just a copy of user, but it's just in the format that Yumi uses for secret keys. Again, Metaplex has their own ways of doing things, so these might be a little bit different than the normal Web3.js ways that we've been using in previous lessons. So we've made our Yumi key pair, and we'll go yumi.use key pair identity, and then Yumi user. And I think we need to import key pair entity, and we need to import key pair identity, so we can get that from Metaplex Foundation Yumi, and that looks good. Excellent. Great. So we've console log, say set up Yumi instance for user. I always like adding console logs, just if we're making command line tools, it's nice to have a little bit of feedback. So we've loaded our user, we've connected to DevNet, we've given the user some DevNet sol if they needed to. We've made a Yumi instance, so we can talk to Metaplex's tools, And we've set that Umi instance up to use our user as the default signer for any transactions. That's good. Let's go make the collection. So we're going to do const collection mint equals generate signer Umi. So it's going to make a key pair using Umi. And this is our transaction that is going to create our collection for us. Await create NFT. As I mentioned before, collections themselves are NFTs. They're just NFTs that point to other NFTs. You can even do fancy things like collections that point to collections. Go check out Metaplex's docs for that. And we'll say Umi and then the options for our collection. Mint will be the collection mint, which is just that key pair we made earlier. The name, let's call it, my collection. Symbol, MC. I don't normally like using symbols for connections, but Solana Explorer says no symbol if you don't have a symbol for your collection. So that's the only reason I like to do it. A URI. I'll talk about this in a second. URI, pardon me. Add that comma. What else? Seller fee basis points, which I will say is a percent amount. Of 0. Seller fee basis points are a way for artists to make money on secondary sales. So if an artist sells an artwork to somebody, then a couple of years later, particularly as that artwork has increased in value, that person transfers it to another person, then the original artist can make a royalty on each of those transactions. That's actually a really good idea. But these days, we actually have newer, better ways of handling this, because this basis points on NFTs used to just be enforced by marketplaces being nice. These days, we actually have things that are built into the protocol, like programmable NFTs and like transfer hooks that can be used to provide a mechanism for artists to get those royalties and enforce them, so people can't actually transfer that artwork without paying the original artists. Very cool, particularly for people who make money as artists for their living. And yeah, if you're interested in that, you should check out Token Extensions. There's a lot of really good things in there. Seller fee basis points and is collection, let's say true. Great. And it looks like we need to import percent amount. That's percent amount. Where do we get that? It's from, Metaplex Foundation Umi. Key pair. So just after key pair identity, let's add percent amount. There we go. And that all looks good. So after we've made our transaction, we can do await transaction dot send and confirm, and we'll use our Umi instance to connect out to Metaplex's tools on the Solana DevNet, and that looks good. So we've loaded our user, given them some Sol, connected to DevNet, created our Umi instances, and created our NFT to represent the collection. We're going to actually fetch the NFT that we've just made. So const created collection NFT equals await fetch digital asset Umi, and then we say collection mint dot public key. Yeah, fetch the NFT for the collection at that address. And then we are done. So console.log. Sometimes it feels like VS Code is heckling me when I type. And I will say, what will I say? Created collection. I will pick a nice emoji for a box, because the box has the collection in it. And I like logging emojis. The address is, and then let's use Get Explorer link. And what do we want? We want a link for the address of our created collection NFT dot mint dot public key, and we want a link for DevNet, please. So that looks good. Let's just run through our script to go through it again. We have our connection to DevNet. We're loading our user from id.json. We're giving them some DevNet sol if we need to. We're creating an instance of Yumi, which we'll use to talk to various tools. And we're saying the specific tools we want to talk to are the MPL token metadata program. In other words, Metaplex. We're creating a Yumi version of our user and saying that Yumi should use that to sign all our transactions. Just making a key pair, then creating an NFT, which is going to make a mint using that address. And that NFT is a collection NFT. So you'll see, is collection true? That is our collection NFT. We're going to send that transaction and then refetch it from that address. We can run this, but first we need to talk about this URI. So that URI should be a JSON file that you've uploaded somewhere and that you can access directly via that URI. For this case, I've just used GitHub's raw URLs. So that's when you upload a file to GitHub, you can click on it and see the raw URL. What you want for that URI or URL, they basically mean the same thing, is that when you load that in your browser, you just see the JSON file. You shouldn't see any HTML or anything else around it. So if you look at my screen right now, it's just straight up JSON. All it has is a name, a description, and an image. Also with that image file, let me show you the same thing. When I load that image, the image just loads itself. No surrounding HTML, no anything else. You'll need both the JSON file and the image file mentioned inside the JSON file to be able to load up directly without anything else around it. Again, in GitHub, you can just use a raw URL, which is fine for our purposes. There's quite a few of these permanent online file storage services. You can pick the one that works for you, but the thing that makes them permanent is they're, like Solana, decentralized. So they can store your JSON file or your image online for a really long time. They're not reliant on any individual cloud provider. So when people buy your NFTs in production, they can know that the JSON and the image will be around online forever. So we've got our image and we've got our JSON file. And when we load either of those URLs, we just see the image or the JSON file. Let's take the address we've uploaded our JSON file to and paste it into our URI field for our collection. So that looks good. We probably also want to install ESRun because we're about to run it. So npm I ESRun. ESRun, if you haven't seen it before, is just a really easy way to run TypeScript on the command line. You don't have to set anything up beforehand, it just works. So now that we've installed ESRun, we can just run our TS file. That's npx ESRun create collection.ts. So we've loaded our user, we've set up an Yumi instance for that user, and you can tell it's thinking. It's going to go make our collection for us. Beautiful. So it's made our collection, and because we did that Git Explorer link, it's even given us a beautiful link to click on. So we can see in Solana Explorer, make that a little bit bigger for you, that our collection has loaded. The symbol is MC. The master edition is a way of saying that this is a collection. And you can see a bunch of different information about this. There's only one of the collection. There'll only ever be one. And it has a bunch of other fields that are common to regular tokens. Things like a mint authority, like who's allowed to make these, a freeze authority, who's allowed to stop them being moved around, and an update authority, who's allowed to change this, which are all just public keys. The update authority you'll see is the public key that matches our id.json file. And if you scroll down, you can see when this NFT was created in the history, you'll see 2 minutes ago that that transaction ran. So that was our transaction running through Yumi. Great. So we have our collection. Let's make an NFT that's a member of our collection. And then let's also verify as the collection owner that that NFT belongs to that collection. we're going to make another script here. And what should we call it? We'll call it just create nft.ts. And I'll save that. I'm going to just copy all the imports and probably the user and the airdrop and the UMI user, because we can reuse all of those. We might not use all the imports, but we can just delete the ones that we don't use. So in create NFT, we've pasted in everything from our previous script all the way up into we set up the UMI instance. The next thing we'll want to do is save the address for our collection, because we're about to use it to make the NFT that belongs to that collection. So let's do const collection address equals, we'll say new public key, public key. And we will get the address from our collection. I'm just going to use our Explorer. We could also get it from the command line. New public key, and that address. It's complaining about public key. It's just because it's unused, but that's okay. And we'll need to import public key from Solana Web3.js. We could also, if we wanted to, do it this way as well. Because UMI has its own format for public keys, we can also just go public key, which is actually a function that comes with UMI, and there we go. That also works. If we do the normal Web3.js method of doing new public key, then later on we'll have to convert it to the UMI public key anyway. So we may as well, which is actually done with the same function, so we may as well just use the function in the first place and just go collection address equals public key, the function, and then the address of our collection that we got from Solana Explorer. So we've got our public key. Let's go make our NFT. Console.log creating NFT ... Oh, sorry. VS Code gave me a great suggestion, which I also don't care about. Creating NFT ... The NFT has its own mint, as again, I mentioned each NFT has a unique mint address because they're unique. Generate Solana UMI. That's going to be just a new key pair that we make. And then let's actually make the transaction to create an NFT. So const transaction equals await create NFT. We'll say our UMI instance, and here's the options for our NFT. The mint will be the mint address we just made. The name of our NFT will be my NFT. The URI will be another off-chain data file. I'll just put ... in there for now. Seller fee basis points, same as earlier. We'll just say %amount 0. And we'll add some information about our collection. We'll say the key of our collection, the public key of our collection, is collection address. If we, actually, I'll tell you about that in a second, and we'll say verified false, just because when we first make this NFT, verified will be set to false. In a second, we're actually going to sign or verify that NFT being part of our collection. And that will change verified to be true for us. Then we'll do await transaction, send and confirm using our UMI instance. So we've made a transaction to create our NFT. We've said that it's a member of the collection that we made a moment ago, and we've sent that transaction off to UMI to be processed and make everything for us on the blockchain. Let's go fetch the NFT we just made. So const created NFT equals await fetch digital asset, and using our UMI instance, we're going to fetch the asset that it's at the NFT's unique mint address, mint.public key. And then let's make a pretty console log. So console log, and I'm going to add a little artwork emoji because that's cool. And we'll say created NFT. Address is, and then we'll do get explorer link for address using created NFT .mint .public key, and we want a link for DevNet, please. That looks good. So that's our whole file. I'll just go and remove any of these imports that we're not using. We ended up not using public key from Web3.js. We ended up just using the public key from Metaplex Foundation UMI. It's a little bit weird, UMI having different formats for public keys from Web3.js, but hopefully that will be fixed in future. I think everybody's moving to the new web crypto style of public keys, so that will get better in future. So finally, before we run this script, I wanted to talk to you about that URI. So just as we saw with the collection, that URI needs to be a file, a JSON file stored online, and that when you open it in your browser, you just see the contents. So I'll open up another tab here and show you. For an NFT, it's just a name, a description. You can add a symbol if you want to. I don't feel like adding a symbol for this one. And an image. The image inside also needs to just load directly when you load it up in your browser. So it's this cool ball with energy bits. That looks nice. Same as before, if you're making NFTs that you are selling in production, use one of these like permanent online file storage services. That means that your JSON file and your image will be online forever. So I will paste in my uploaded, oops, not the image file. I want the JSON file. There we go. And I will run our script. So just clear my screen, npx es run, and then create nft.ts. Let's make our NFT. So it's loaded our user, set up our UMI instance, and it's making our NFT for us. Give it a moment. Great, we've made our NFT. So if we click on that URL, I use a Mac, so it's command click to open up a URL. We can now see our NFT. It has the artwork, that is the artwork that we uploaded before. This actually, NFTs can have a bunch of different files. This just happens to be an image, but we could also use an MP4 video. We could use a 3D object like an FBX file or an OBJ. The name of our NFT is the name from the JSON file. We didn't set up a symbol, so it says no symbol was found. And yeah, it's a bunch of other normal token options, like there's a maximum of one of them, and there's only one of them supplied because NFTs, if you look at them as being regular tokens, are unique. Seller fee basis points is 0%, as we said earlier. And you can see that it was created a couple of minutes ago, 2 minutes ago, in fact. We didn't set up any attributes on our NFT, and if you look in metadata, you can see a bunch of things like where the JSON file is, which is where it got that image from. And you can see the creator. The creator is 0. The first creator is our address from id.json. And you can see the collection, which is the collection that ch file, that ch public key that matches our collection that we made a moment ago. You'll see that verified is 0. Let's verify that NFT as being part of that collection so that it turns that verified to 1. Also, art tools, particularly wallets or galleries or art marketplaces, really like it if you have verified set to 1. There used to be that people would run around and make an NFT that was a fake NFT that looked like it was a member of a real collection. So having verified NFTs is a way for the collection owner to say, yes, this NFT is a part of my collection. So let's do that now. We're going to make a new file, and we'll call it verifynft.ts. And because I don't like typing, I'm going to steal everything from that first file again. So just loading up our user, giving them some Solana, setting up our UMI instance, and yeah, all the way to set up UMI instance for user. So I'll just paste that in. And to verify an NFT, it's actually pretty simple. It's only yet another, just a single transaction. So we've made our create NFT script, and we've pasted in everything all the way up to setting up our UMI instance. We'll need to set up our collection address. I will steal that from our create NFT script. And we also need to set up our NFT address, NFT. And what was our NFT address? I'll get it from Solana Explorer. 84 something or other. That sounds good. And it looks like we need to import that public key, that function, which is part of UMI. There we go. Cool. So we have just a pretty default UMI script with a collection address and NFT address set up for us. So we've pasted in our collection address and our NFT address into verifynft.ts. The only thing left to do is actually make that transaction that verifies that this NFT is a member of this collection, and that will flip that is verified to true on the NFT. So let's make that transaction. Const transaction equals await, and it's called verify collection v1, and it takes an UMI instance and a bunch of options. The options are the metadata, and this is the metadata for the NFT that we want to verify. We'll actually use a little helper. It's called find meta PDA. It comes with Metaplex. And we'll just give it the options. Find the NFT, find the metadata PDA for this mint, which is our NFT address. NFT address. Beautiful. The collection mint, which is our collection address. Nice. And an authority, which we'll actually just say is the user running UMI. So if you do UMI.identity, that is our authority. We could also say authority is UMI user. Same thing. It just means one says it's this particular key pair. The other, it says it's whoever is running UMI, which is also the same user account, the one from our id.json. So we do transaction dot send and confirm UMI. Beautiful. And then we'll do console.log, and let's use some cool emojis. I will use a big old tick for being verified, and we'll say NFT verified, and let's give it the NFT's address. NFT as member of collection, and we can say collection address, and let's also say see explorer at, and we'll say get explorer link for an address, which is the NFT address on DevNet. That looks good. Excellent. I'll just save it and format it. And everything looks good. I can remove some of those unused imports. Don't have to, but I just want to keep our file nice and ensure there's no dead code. Let's go and run our verify nft.ts. I'll clear my screen and do npx esrun verify nft.ts. Give it a moment to run. And it looks like it's finished already. That was really quick. Let's go check our NFT. And what we're looking for here is in the metadata. There we go. Verified is now set to 1. Explorer actually updated while I was looking at there. I was worried for a second. Yeah, cool. Great. So our NFT is now verified as a member of that collection. So now we have a beautiful NFT. If we click creators, our wallet address is shown as being the creator. That NFT is verified as being a member of a collection, which means that wallets and galleries and art auction sites will show our NFT nicely because it's important that NFTs are verified as being parts of collections. We have a beautiful collection. And yeah, we can transfer this NFT to people. We can set it up on auction sites. We can make dApps that use this NFT to like token gate access to something. That can be a real world experience or a digital experience. If you want to learn more about Metaplex's tools that we were using in this lesson, the tool we were using is called MPL Token Metadata. So if you Google that, you'll find all the documentation about that tool. And if you want to learn more about Solana, I will see you in the next lesson.